Hi, this is Abdul Bharti and welcome to another episode of TFI Newsroom. And today we have a team from Red Hat where we're going to talk about networking and Kubernetes. So first of all, welcome to the show. Would you like to introduce yourself first?
Yeah, hi, good afternoon, Swapul. My name's Tom Nadeau. I'm from the Office of CTO at Red Hat, where I'm involved in all things networking.
I'm Amnon Ilan. I'm managing several teams in RHEL virtualization and networking groups, engineering.
Ariel Adam, also in the real networking, managing VirtIO networking inside there.
What is this kind of landscape looks like when it comes to networking in context of cloud ready or Kubernetes space?
The networking space is actually very complicated, very crowded. There's a variety of solutions in this space: Calico, Flannel, etc. And we, how we got to working on vDPA was to kind of take a more short-term approach. Those other approaches are trying to solve kind of bigger problems or trying to solve a bigger space of problems, I guess. Our goal here was really to sort of extend the progress we've made first with DPDK, then with SRIOV, and connecting those things then to virtual machines, and now connecting those directly up to containers so you can get high-speed accelerated and hardware accelerated forwarding directly for containers.
What specific problem are you trying to solve with vDPA? As you mentioned, there are already so many projects.
So with the vDPA, we are trying to solve the problem of a generic driver inside containers. So today with containers, if you want to have an high-speed container, you just connect it using Maltos and SRIOV, and you have a direct access to your NIC, and you have a high-speed line to your NIC. But the problem is this is not a generic driver inside the container. You need a very specific driver inside the container to drive the specific hardware that you're connected to. And this is problematic in terms of scaling and supporting this kind of containers, because then you have to care about where it runs, which is exactly the opposite of what Kubernetes is trying to do, like abstract all your hardware. So this is where vDPA is coming to the picture to solve this specific problem and have a generic driver inside your container that can run everywhere, but in wire speed, same like SRIOV links.
So in a single word, what we're trying to solve, we're trying to address the problem of certification of containers. We want to solve the problem of certifying special containers, and VMs, by the way, that need accelerated interfaces. Okay, not the standard container. So any container that needs to run high loads currently is vendor specific for the public cloud or the on-prem. What we're trying to find is a way to have a single image that can run over any public cloud or any on-prem cloud. That's the overall problem we're trying to solve.
The certification part is one of those hidden gotchas that we've noticed deploying Kubernetes and OpenShift on a wide scale. What we found is that it turns into a combinatorial nightmare, basically, where you've got to, like Ariel was just saying, you've got to certify it on this thing, on that thing, on this one, and then maybe in the future on other things that you don't know. And this just simply adds additional cost to the whole picture, and operationally, it's not a very friendly thing either. You should just be able to have the generic driver and enjoy it was a discussion like yesterday with Mellanox. You should be able to enjoy 1 gig or 100 gig performance for your container and not have to do anything different other than plug in a new card.
What are the use cases you are looking at when you, from this project's perspective?
The use case is pretty generic. The goal is, what you want to do is build a base image that is common for all of your containers, whether you want the container to contain a virtual router or a database. And again, it's what Amnon was saying is one of the top 5 goals of Kubernetes is simplicity of operations and creation of the application or the microservice eventually. and having to worry about what all these underlying details are kind of what hindered a lot of the OpenStack deployments, where you had to do a lot of complicated things in Neutron to kind of plug things together in a certain way. And that turns out to be very fragile in terms of operationally, because like I was saying earlier, the next platform that comes around that you decide to buy and deploy might have different NICs in it, for example, from a different vendor. And all of a sudden, I got to go back and not only sort of augment every one of these images or create a new base image for new containers that's special, but then I have to certify that. And basically certifying that means N times containers times my new platform. And so you've got an N times M kind of combinatoric thing here that we're trying to turn into just N.
Yeah, just to explain it a bit. So you just want to run a single application in your container. Let's say you're just doing an HTTP daemon inside your container, but then you need to have 10 different versions of the image of this container just for different NICs. And here you just make one generic image for this HTTP server that you.
The reason you have to do is because today, in order to accelerate your container, you have to push the NICs driver into your image. For example, SRV, that means that you actually have to compile the image of your containerized application that has nothing to do with a specific NIC with that driver in order for that application to talk with DPDK, for example, all the way down to the NIC. And that means that goes back to what Tom talked about, the endless permutations of certifying every possible NIC on every possible cloud, and that simply doesn't scale. That is so expensive. We know that.
And it doesn't scale in two different ways, by the way. It's not just operationally, you've got all these different things to manage and troubleshoot when they break, because now you've got different drivers. You've literally got different things to go manage. But then the certification thing, and then maybe the compatibility thing, right? So in the future, now I've got to worry about if I want to deploy a next generation NIC, you got to think, oh God, I've got to go back and touch everything in my network.
Or even think the simplest problem: you have a cluster. Now you want to use SRV, you want to do things fast, and any edge use case, any telco use case goes with SRV, DPDK for CNFs. So if you have two nodes now, physical nodes, and they have different NICs, that means that you can't even properly scale your image, because if you take your CNF and when you want to scale it or heal it to the other node, that's not going to work for you, because that's a different image, because that's a different driver. So today in practice, Kubernetes is very very naive when it comes to really manage loads that require high networking, faster, low latency, by the way.
Project was announced or introduced in October.
So the vDPA project started as an idea about 2.5 years ago. It was introduced in DPDK conference in Shanghai by folks from Intel. And it evolved since then. We have been working on it, developing the VirtIO specification with the right type of ring layout that can really talk directly to the hardware, and the right drivers and the right software infrastructure for it in the Linux kernel, in DPDK, in QEMU, in all these projects to enable this technology.
The ring layout is different for every different NIC. Different vendors have different strategies, and that's the sort of the value that they bring to the party. The problem is that's directly what requires a special driver to talk to that implementation detail. We're trying. Right. That's what we're trying to abstract away for the user and for the container.
So the abstract contains two parts. One part on the container side is put a generic driver, but the other part is work with all the NIC vendors to implement a standard ring layout or a data plane inside their NICs. That's obviously the big challenge, but we're making very good progress, because I think eventually the ecosystem kind of led the different NIC vendors to start implementing this. So we're going to start seeing cards, and between 12 months to 18 months, working with this data plane, which is standard, and then it can connect this generic driver on your container and give that additional value.
Who are you working with? You mentioned is originally started with Intel, and you mentioned Mellanox. Who else are you working from the hardware community?
Intel, Mellanox, Marvell, Broadcom, Metronome, exciting Solarflare. We're also talking with Cisco. Basically, any major NIC vendor has this on their roadmap. That is, and not as a future POC, but actually something to get done because they understand it's happening.
And they understand why this is important too. I mean, one of the kind of the implicit things that is underneath here that might not be obvious, but is that portability too of your image. You know, we're talking about like maybe in a single data center, you own all the hardware, but when you want cloud portability, when you want to use multi-cloud, cloud providers also have their own drivers for the VNIC implementations, and this is another issue. So if you want to go from cloud provider A to cloud provider B next week, now I've got another, back to the combination thing we were talking about at the beginning.
Is the project, led by Red Hat? Is it part of CNCF, vDPA? What does the governance look like for the project?
So I'll just I'm going to jump into this. Basically, as pointed out, the challenge of this project in practice, it is very, very complicated because it involves so many different open source projects. Okay, part of what we do is in the kernel. Part of what we do is in QEMU libra relating to VMs. Part of what we do is in DPDK. Part of what we do is in Kubernetes. And because we have so many different communities upstream working in this, and we also have the certification of the VirtIO SPIC. So that's another community we need to engage with. So what we did is basically we created this kind of a light community called VirtIO Networking. We've got monthly meetings. We've got a mailing list. And the idea is kind of to create an umbrella for all the different segments of work currently being done and to consolidate everything. For example, we help NIC vendors that want to jump into this, enable them. What do they actually need to do in order to implement it? How can they push in something? How can they enhance the spec? So the purpose of the VirtIO networking, where you're going to see a lot of blogs on, is to enable anyone who wants to join these communities to focus what do they need to do and where.
How does it work with the other networking project like HTO or other service mesh project which are at CNCF?
So actually, what vDPA does is adding another layer of abstraction on top of SRLV. So it's kind of orthogonal to the full picture of the Kubernetes networking, all the CNIs, Istio, and all this stuff. It works on any NIC, on any SRLV device. It will also work on vDPA interfaces. So it abstracts the interface on top of SRLV, and it works with any other networking on top of it.
You're working with the hardware vendors for certification, or you're also working with the community? Can you talk about that a bit? How do you ensure that? Because you will be working with a lot of other components that are involved, both from hardware perspective as well as software components, which are a lot of them are open source.
Well, there's multiple certifications involved here. The VirtIO certification Amnon was talking about, that's one thing. We also have container image on platform certification as a completely separate thing that is done in a couple of different places as well. Like we personally spend a lot of time and effort certifying vendors' container images on OpenShift, Red Hat OpenShift, for example. That's just a kind of a value add that we do.
So it's less about actual certification, more about the standard. So VirtIO is a standard, an open standard, and this standard is actually being defined in an open source way. So all the hardware vendors we mentioned are participating in these discussions and creating this standard. And then anything built on top of this standard is compatible with the vDPA way of doing it.
And to add on that's where the complexity comes into play, because the standard in practice is implemented parts in the kernel, parts in QEMU, part in the DPDK. So in order for really to someone come and use this, they need to be, everything is open source, it's different communities, but they need to be able to use the relevant Git and code sources and properly integrate with them. So if a vendor wants to come and work, it's not enough for him only to do the hardware enablement. He also needs to develop the relevant drivers on the DPDK side or the kernel side. So because of that complexity, our goal is to enable them, to simplify as much as possible, to have very simple APIs, to have a very clear spec that is well accepted and defined and maintained, that's where kind of the place we come into play in assisting.
How concerned are you when it comes to security in this space? How are you addressing security with vDPA?
Yeah, there are many important points in this technology that bring more security than let's say the normal containers. So one point of it is the way it's integrated with virtual machines. So the fact that you have a single standard that works both inside container and inside a virtual machine gives you this flexibility to move to a more secured. A virtual machine is considered more secure than a container, and you have a lot of combinations between containers and virtual machines that span the security levels there. And this technology can work with all these types of technologies. And on top of that, using DPDK also enables you to bypass some of the system services. So you need to use less system calls when you use DPDK application, which brings also security value to the picture. So there are actually different levels where you gain more security with this technology.
And there's one little thing to add to that too, like the kind of the traditional MO for security is more is less. And so the other approach to this is load all the drivers again into the container. Again, it's security folks that I worked with all the time tell me less stuff inside of these. A container, for example, is just easier to certify, less things to worry about.
You actually can invest much more in certifying this specific image in all your combinations, including security, instead of having 25 different types of images for different clouds or NICs that you have to deal with. So on the long term, it is much easier. And as everyone pointed out, this is also the same interface we would use for VMs.
Getting to this point of same infrastructure for containers and VM. So there's another very important use case, and this is the migration from today's VM-based installation to future container-based installations. So telcos today are developing VNFs, which run on virtual machine. And now they will want to take these VNFs and make them a CNF that runs in a container. And with this approach, they have nothing to do. They just take their VNF, it's already with the DPDK driver of VirtIO, and put it inside a container, it will work. So this migration, very important use case, is also covered very well with this generic interface.
What does the roadmap look like, or how is the cadence of the project is? Can you talk a bit about that?
One part of the work that we do is basically the engine, which is used for VMs and containers, and the other part is what we're doing in Kubernetes. We have multiple teams working in this with multiple companies, by the way, and we're treating this as a proper product, not only as a project, including CI frameworks and getting multiple companies to really verify that the solution sticks. And it's a challenge because currently the cars are being developed as we speak. So one part, the DPDK part is completed overall. That's something solid. It's upstream. Anyone can go download it, work with that. The kernel part is in very advanced stages. A number of upstream discussions, but it's being finalized. And the third part, Kubernetes, we started that a few months back, and currently this is also being pushed with the relevant communities. We'd expect to see something solid in about 6 months. That is, we expect to see the kernel part being pretty much, completed from our side in about 2-3 months, then moving on to Kubernetes about 6 months.
Yeah, on top of that, we'll add, of course, QEMU and libvirt support, and then it will get into OpenStack as well. So we'll have support both in Kubernetes, in OpenShift, and in OpenStack.
So then we'll have Linux, RHEL, Kubernetes, and OpenShift.
And is it already in the Linux kernel?
So if you open that, you'll find many of the blocks in the kernel. Actually, by the way, just to kind of involve you in discussions we have in the community, this is a very hot topic. So there are many opinions on how this should be done, especially in the kernel upstream community, and very emotional discussions. So by the way, there were a number of models that we actually completed, but now we are refactoring them following comments from upstream, because it is so important for us to have a coalition and an agreement from all the stakeholders on this. If you go into the kernel today, you can find many of these components already there.
Awesome. Thank you so much for taking your time out and explaining the project to me. I look forward to seeing you all again at some point, and Tom most probably will see you at the networking summit or whatever new name they have come up with.
ONS++.
Thank you.
Yeah, thank you
Yeah,
very much.
ONS++.
Thank you very much. I appreciate your time.